Hello, Devnexus. Hope everybody's having a great conference. In this session, I want to talk about how I have started implementing unit tests of my Java architecture. We're going to talk about a library called ArchUnit that I use to do that. I'm going to talk a little bit about my motivations for wanting to do something as audacious as unit testing in architecture, and hopefully show you some useful code snippets of what those tests look like and what you're going to get out of them. When I'm talking about architecture, I'm not talking about a large systems architecture. I'm talking about the architecture of a single application or microservice. And what I've defined as architecture is it's the set of design patterns, organization, and conventions that help developers understand the code and that enhance its changeability. And typically when we say enhance changeability, what we're really saying is I want to isolate different responsibilities in different layers of the application. So it's hard to accidentally break something in another area when you're making. If you were to sit down and try to define an application architecture and capture that as a document, you'd end up asking or answering a lot of questions. Things like what kind of architectural patterns are we using? Is this a microservice or a monolith? What are the platforms or frameworks? Spring, are we using Hibernate? What parts of the application do we know need to be replaceable or have multiple implementations? And how do we make sure that we can easily, replace those things? You'd probably have to document, how you want to manage dependencies, things like naming conventions and coding conventions, how you organize source code, into layers or into responsibilities. There's just a lot of stuff. And when it comes to actually creating such a document, enterprise IT has a problem. In my experience, enterprise IT, most of the shops are very sharply focused on adding new functionality. They don't get paid to support and enhance the code that's already out there. They get paid to put new features out into production. And so there's a little bit less focus on things like technical quality and refactoring. These shops are typically a mix of in-house and outsourced teams. The developers who are employees are typically your lead developers or your architects, and they're running at 100 to 110% capacity. They're involved in every project that's going on that involves enhancing this code, and so they're not necessarily available for every PR to do a code review due to their lack of time and to management's, putting less importance on documentation. It really is a low priority, and most of the architectural decisions are handed down verbally from developer to developer, or the lead developers basically hope that the code speaks for itself and that you should just be able to read the code and know where to add, new controllers or new domain classes, etc. But what really happens is that you get these developers coming in who are new. There's no documentation on what the architecture is supposed to look like, or there's very little. And they're given the task to start implementing new features or fixing bugs or enhancing existing features. So they're gonna check in code that does not meet the current definition of the architecture. Somebody will check in code that doesn't follow an established naming convention, or they don't realize that all of their DTOs are supposed to be in this package, and so they end up adding it in the wrong package. So what happens is over time, the structure of the code gradually erodes. And what started out as, pictured by the lead developers and architects as being this nice structured layered architecture ends up being the big ball of mud. So what my teams are working on to try to help those senior developers make sure that the architecture remains as it's defined is we're starting to lean on automation and tooling. So the teams I'm currently working with have a strong unit test discipline. They not just write and run their unit tests. They measure coverage. They're expecting new code to have an 80% or higher coverage rate. They're also running their code through static code analysis tools like SonarQube or PMD or Find Bugs. We're also leaning on the IDE for doing automatic formatting, but we can, after the fact, check that formatting using tools like SonarQube or CheckStyle. To those sets of tools, we'd also like the ability to add in some checks to make sure that files are being added in the right place in the architecture. You know, things that belong to the DTO layer are put into that layer of code, into that package of code. Things that are implementing REST controllers are in the appropriate layer of code for that. You can do a lot of those types of checks in tools like SonarQube, but we're starting to look at using ArchUnit for that instead. And there's a few reasons why. ArchUnit is a freely available open source, free as in pizza, under the Apache 2.0 license. It's pretty easy to get approval to pull into an enterprise IT shop. It has a great website. If you want to know a lot more than I can cover in 20 minutes about ArchUnit, I say go to the website and start reading. So these are some of the reasons why I chose ArchUnit. You know, it comes with, as you would expect, a number of predefined rules for checking Java best practices. More important than that, it has an expressive API, you might call it a domain-specific language, for building your own rules. If you've ever tried to add a rule in a tool like Find Bugs or PMD, you'll find that you often have to learn a new language or a new framework, or you're going to go off and do coding in some other project and end up exporting a new jar file to put into your build. You don't have to do that here with ArchUnit. You can actually write you can write your rules in Java in your unit tests and not waste any effort doing things outside of your application. And really important, you can use your existing test framework. You don't have to have a separate server like Sonar. You can run the test immediately inside your IDE. And that's really important, because what we want to do is we want to get the developers to the point where they write some code, they run their unit test, they check in the code, and if all the unit tests pass, they check in the code, and the CI build kicks off. If I can add architectural based tests to that, then they're going to find out when they violate an architectural rule really only minutes after they've made that mistake. Instead of waiting for a build and a Sonar analysis to run, offline and return some results at some other time, they're going to get this feedback right now. So let's get started with ArchUnit. To get started with ArchUnit, we really have to just add a jar file to my class path, and I'm using a Maven project here, so I'm going to add a dependency here in the POM file. Once that's there, we can actually add our first architectural test. So I'm going to do that now. What I'm going to do is I'm going to tell ArchUnit what classes to analyze, and I'm going to store that off into a field of this test class called imported classes. And now I'm writing my first actual test. Okay, so this test looks for code that throws either runtime exception or exception, which we would consider generic exceptions. We know it's a good practice to actually throw specific exceptions that indicate what the problem actually is. And so this rule is going to help us enforce that in our architecture. So now that I've got this class, let's run it. And it tells me that there are in fact violations of this test. It tells me it's an architectural violation. No classes should throw generic exceptions. It was violated one time. And it tells me that my portadapter.getAddressBook method calls a constructor of a runtime exception. Let's go fix that and verify that that removes this JUnit failure. All right, cool. This is sort of a standard JUnit setup. I'm using JUnit 5, but other than that, it looks like any other JUnit that we've used, right? So I've got this code that basically acts as my setup method. I'm telling ArchUnit to import the classes, and then within a method that's annotated with test, I tell it to check those classes against this rule. ArchUnit does have a more succinct way of expressing this exact same test. We can see that I can use some ArchUnit annotations to more succinctly express the same thing. The thing on the left is the one I just wrote. The thing on the right is using the new ArchUnit annotations to make the code shorter. So here we're using an annotation to tell ArchUnit what classes we're going to analyze for all of the tests in this test class. And then instead of creating a method with the test annotation and then inside that method firing off one of these rules, we just create an instance variable that is equal to the rule that we want to fire, and then we put the arc test annotation on it. So let's run this test instead. They should be the equivalent. We should also see green here. And indeed we do. You can use this pattern to add a lot of other tests. I'm going to add a few here. This first new rule that we've added is it detects uses of system.out or system.in. It's just a generally good Java practice to use logging instead of writing to standard out. So that's what this is catching. This next rule is checking for package cycles, and it demonstrates using the slices feature of ArchUnit. A slice in ArchUnit is a group of packages that are related in some way to which you want to apply some rules. This particular rule actually looks at every package and subpackage as its own slice, and so what we're doing here is verifying that there are no dependency cycles between any two of the packages within this application. If you wanted to check a specific set of packages with a given name, you can expand upon this, and as we can see in my class hierarchy, I actually have a fair number of classes that are underneath this adapter package. And so changing the rule like this would be only selecting these the adapter package and its sub packages. Let's add another custom test just so you can get a feel for this syntax. I'm going to create a custom test that says all of my exceptions must inherit from a root exception within my code base, which I call component exception. And so we're adding that test now. Okay. So what this illustrates is how most of our custom exceptions are written. Just like the slices definition said, define the slices and then tell me what they should be free of cycles. All of our custom rules work like that. The first part of them is a predicate that identifies the set of classes that we're going to run the rules against. The second part of it is what is the rule itself, and it's defined as another predicate. Okay, so in this case we're saying that none of my classes, with the exception of component exception itself, should call a constructor that is in a class that is assignable to throwable, but not also assignable to component exception. So we're really saying, again, that all of the exceptions created by this application must inherit from component exception. We're going to add the because clause on there. If I run this, we're going to see that I do have some violations of this. It's been violated 5 times. I can also see that as part of this stack trace, it has my text from the because clause in here. So it's right down here, because all exceptions thrown by this code must inherit from component exception. I'm going to show you another really cool feature of ArchUnit. Often when you introduce a new rule like this one, there's already a number of violations of it. There might be so many of them that, in fact, it's not really practical to get the team to try to remove all of them as soon as you implement the rule. Instead, you're going to take an approach of, let's prevent any new violations of this rule, and then we can work on refactoring the code later to remove the old violations. And this is something that ArchUnit actually handles using a feature that they call freezing arc rules. And it's just as easy as saying I want to freeze an existing rule like this. So now our no non-component exceptions rule is now a freezing arc rule. To make that really work, you're going to need to create an ArchUnit.properties file that's on the class path, and you're going to need it to set this allow store creation to be true. So what it's going to do is when we run this test, it's going to capture all of the current violations and store them in a store, and then it will ignore those when doing future analysis of this rule. Okay, so we had 5 or so violations of this rule. Now we've got 0, and we've got 2 new files in our file system. We've got this stored rules file, and what this stored rules file does is it captures which rules are being frozen. So we can see our no component exception rule is one of the rules that have been frozen, the only one so far. And we also have a file that contains the current violations of this rule. So now if I create a new violation of this rule, it should only give me that one. I'm just going to have some code throw an exception, and then I'm going to create that exception and make sure that it inherits from runtime exception instead of our component exception. And now I'm going to rerun our arc rules with the freezing rule in place. So we have a new violation of this rule, and it is this my exception class. That's the only one that's causing this. I've got one last thing to show you before I wrap it up, and that is how ArchUnit enforces a layered architecture. This is from the ArchUnit documentation. It shows a 3-layer application with a front-end controller, a back-end service layer, and then a persistence layer underneath that. And we're basically saying that the controller layer is not accessed by either of the other 2 layers, and the service layer can only be accessed by the controller, and the persistence layer can only be accessed by the service layer. And so this is the ArchUnit rule that you would create to enforce that access. Besides the layered architecture, ArchUnit has support out of the box for what is sometimes called the hexagonal or onion or clean architecture. And in fact, that's the model that we're using in this application. So you can see here is the architectural rule, the ArchUnit rule that verifies that the chain of dependencies are all pointing in the right direction for this hexagonal architecture. So hopefully you've seen today how useful a tool ArchUnit is, and maybe I've given you some inspiration to go out and check out this tool. Again, something that I highly recommend you guys look at. And just as a reminder, my name is Jeff Wilson, and my contact information is at the bottom. If you want to talk to me about ArchUnit or anything else, I'd be glad to talk to you after the conference. Have a good day, everyone.